what is a histogram, guys? See, histogram is nothing but it is a frequency counting. Okay, it counts the frequency. Like you can just check one particular, yeah, attendance. Okay, attendance of a student in a class, or attendance of all students in a class, or the ranking of students. Okay, now in the ranking of students, if you see, say up to 33 or 33%, okay, how many students? Or next 33 to say 50, how many students? Okay, 50 to 75. Okay, 75 to 100. Okay, so here how many, whenever we call it as how many, that means it is frequency counting. This many occurrences. Okay, so histograms are generally used to see the frequency distribution of any data. Okay. Now let us see how to create a histogram. Let us just take sales. Okay. So in the y-axis, instead of sales, instead of sum, what we will do is so here, instead of summarizing, let us take it as don't summarize. Okay, now you can see total sales. Okay, now here okay, instead of sum, we do not have the actual values. Okay, okay, just a minute. Y-axis, let us put count of sales, but it is not for individual. Now what we can have is category. Okay, now count of thing. So this is the frequency distribution. So you can see here how many times each category has occurred. Okay, are you able to see the count of records? 6026. 2121 and here 1847. Okay, so histograms are actually histograms can be built using single uh, visualization itself. Okay, we can create bands or the bins basically. So when we put some other category there, let's have a category or region. So it will show the frequency of or number of records for each of the region. So let us just see if we have histogram for so let's just add this. Okay, now let us just select this histogram. It is given. You can see the count of histogram. 6, 5, 6, 7. Okay. So now let us see about the next visualization, basic area chart. Okay. So area chart is pretty similar to line charts. Okay. Only difference is that the area will be visible. Okay. Let us select say order date. Okay. Let us select say sales. Okay, here for sales, let us not use this don't summarize. Let us use just summarize. So here you can see this particular chart. Just a minute, area chart. So we have the order date, and let us select profit also. Okay. Are you able to see these two visualizations? Let us drill upward. Okay. Now you can see this area. Okay. You can see this. This is the sum of sales. You can differentiate by color. And this color is related to, okay, sum of profit, this area. So profit size is very less compared to sales size. Are you all getting what are the area charts? Okay. Now 𝐶𝐚 chart we have seen already, isn't it, guys? We have seen 𝐶𝐚 chart already. Yeah, this is the 𝐶𝐚 chart. Okay, which will have multiple measures or multiple quantitative fields. Okay. Customize relation title background. Okay. So here let us just select this. Let us see the title. So if you want to see the title or saturate the title, just select general here. Are you able to see title on? You can off. The title will disappear. Subcategory and order date sales. Okay. So you can change the font size. So here we can see the alignment. Okay, right alignment, left alignment, center alignment, and the color text. So these are the options available for this customization, title, background, and legend. Background we have already seen, right? So here we have the x-axis, y-axis detail. So for some of you, if x-axis or y-axis is not visible, okay. So we have seen formatting of x and y-axis in all aspects, right? Okay. So for each axis, you have this special requirements. If you want to make, you can change it. You can customize it. You can change the font size. You can change the text size. You can choose the colors. Now let us see donut charts in Power BI. Okay, so donut chart, why is it used, right? So donut chart looks like this. Let me just, this is donut chart. It is pretty similar to pie chart. So you need not panic. What is donut chart? Okay, let me just select few category versus sales. Okay, now we can just focus on this. Now this is a donut chart. Okay, now what do you understand by this? So pie charts, remember guys, pie charts are used to show proportion contributed by each individual category. Is that clear? Proportion contributed by that particular individual. So this color will be filled with this, and this with this, and this. Okay. So always remember pie charts, donut charts, they are used to represent the percentage contributed by each individual value. Okay. So here, based on the higher area or higher percentage, then we can judge that is that category is contributing to highest sales, and the category that is having the lowest is shown here. Of course, these are pretty much comparable. You cannot distinguish unless you have this value. And when there are too many, uh, categories, let us just use, okay. Okay, now let us select subcategory versus sales, and let us choose donut chart. Okay. Now, guys, what is your opinion on about this particular visualization? Categorical values that are available, and it is looking very clumsy, isn't it?
Yes, sir.
Okay. So it is difficult to interpret, difficult to read, and difficult to understand, and difficult to interpret such visualizations. Okay. So instead of that, instead of donut chart or pie chart, for a field which is having, say, more than 5 subcategories, okay, or more than 5 values, then it is not recommended to have pie charts or donut charts. Is that clear? So when the categorical values are more than 5, it is better to go for tree maps instead of pie charts or donut charts. It is better to go for tree maps. Is that clear? So we can go back. So scatter plots. Before getting into scatter plots, guys, uh, why scatter plots are used? Let's understand the basics. Then we get into the topic. Why scatter plots are used? Like pie charts, they are used to see the proportion contributed by each individual. Similarly, scatter plots purpose of scatter plot is to establish relationship between two quantitative fields. I am repeating, the purpose of scatter plot is to understand the relationship between two quantitative fields. Okay, let us just understand it with one example. See, uh, as a student, you might have studied for X hours and you might have got, say, X, Y marks. Say, let me put it. So, number of hours studied. Okay. A student generally, the students generally they study before the exams, isn't it, guys? Okay. You might have all done. We have also done those things. Okay. Just before the exams, you'll be reading, isn't it? Okay. So, how does this time spent on studying affect the student's performance in the exam? Okay, this is the thing we want to establish, or we want to understand the relationship between number of hours studied and the marks scored. So here, say some student, say student A, he has studied for 6 hours and scored 60 marks. Student B has studied for 8 hours and he scored 85 marks. Okay. Student C studied for 10 hours, may have scored for 75 marks or any such thing. Okay. So here, if you plot, if you create a plot between these two numericals, okay, these two numbers actually. This is one data set, this is another data set. Okay. If you plot numbers, if you plot these individual data points on the scatter plot, so what you will be getting is something like this. Okay, so like this, there will be data points. So when you try to draw a line connecting these data points, what will happen is some data points fall on this line, some data points are away from this line. Okay. So this line of best fit, this whatever line is there between the data points, that is called line of best fit. Okay. Now this line of best fit, how it is defined? There is some relationship. You might have all studied, this. So here, this is line of best fit. So here this is y, this is x. So m is nothing but slope. Okay. M is the slope. Slope means okay. M is slope. Slope is equal to, for 1 unit change in x, what is the change in y? Okay. Okay. For each change in x, what is the change in y? That is m equal to dy by dx. Okay. This is called slope. So if you extend this, okay, that is m. And what is c? C is constant value. That means whenever this x becomes 0, automatically this entire term will become 0. Okay. Now at that stage, when you extend this line, so wherever it touches the y-axis, okay, wherever it touches the y-axis, okay, okay. So this constant is also called intercept. Okay, that means whenever x value is 0, this entire time becomes 0, then whatever is the y value, that has to be taken. Okay. So here in the scatter plot, we are trying to establish a relationship between two numerical variables. Okay. Like we have, yeah, in the COVID-19 times, so especially towards the end of the second wave or subsequently, so as the vaccination drive has began and it has picked up, so what has happened, guys? As number of people are getting vaccinated, okay, what could be the effect on number of active cases? It will be reduced, right? Okay, that means what? They are
Inversely
they
related.
inversely proportional, right?
Yeah.
Okay. So, but there will be some relationship between them, between these two numerical or between these two fields. Okay, right? So that relationship will be coming out through this y equal to mx plus c. Okay. So we could study the, now let us try to create a scatter plot between two variables. Okay. So this is the data set, guys. You can see we have the location, windmill name, power output, and wind speed. Okay. So let us just load. Okay. Now here we can see windmill data set. So let us select these two parameters. Okay. And let us select the scatter chart. Now you can see that we have only one data point. Are you able to see only one data point? So why we have got only one data point? It is because all the power output got summed up on the x-axis, okay, and all the wind speed got summed up on the y-axis. Now out of these, do you guys know the windmill? Okay, windmill is nothing but a another renewable energy source where you have the blades here. Okay, okay, these windmills are generally installed on the seashores or on hilly areas wherever you get lot of wind. Okay, so the wind speed is converted into, whenever the wind touches these blades, the wind turbine rotates, so it gets converted into electricity. Wind speed is captured and it is converted into electricity. Okay, that is the windmill. So here, what is the input, what is the output base, what is the x variable, what is the y variable? Is this correct? Is power output x variable? Power output is output, right? It is the end result. So it must be in y-axis, isn't it, guys? So we need to interchange these things actually. Okay. So here in the x-axis, let us put wind speed. Wind speed is the input, right? And power output is the output. Okay, here why it is getting summed up, why it is getting only one data point is because they are getting summed up. Okay, so let us remove the aggregation, don't summarize, and here also let us use do not summarize. Okay, now are you able to see the scatter plot? We can focus. So this is how we need to make the plots, scatter plots.